Assalamualaikum warahmatullahi wabarakatuh and good day to Dr. Shahjahan. Today we will present our additive manufacturing project titled Orthopedic Hip Replacement Socket in Medical Industry. As an introduction, the medical sector has been one of the main consumers of the production of additive manufacturing. It is one of the sector where the twin benefits of complex component design, independence and personalization of additive manufacturing can really be used. Conventional total hip arthroplasty (THA) has concentrated for several years on medializing the center of rotation (COR) of the prosthetic relative to the native COR in order to compensate for the spike. This was done by medializing the acetabular portion and using femoral offset. AM could reduce the number of production stages of manufacturing of medical parts, material waste during manufacturing, inventory, remove the amount of tooling needed, and produce the whole component in less time and cost by properly applying this technology in medical. This concept should be extended to the many orthopedic components to manufacture implant and scaffold. Our aim in this project is to be able to design a complex customization component of the acetabular cup for hip replacement for user use in medical industry. There are three objectives in this project. First is to analyze and improve existing product design through AM principle and approach. Second, to enhance the product ability, the economic environmental impact on value chain, and third is to advance the engineer's ability to design complex parts or product by using AM. Our scope in this project is using selective laser melting (SLM) and undergo economical and technical analysis.
Now, we continue with literature review. Firstly, about acetabula cup, the article from Dal Ava 2019 entitled 3D printing acetabula cup for total hip arthroplasty. In this article, explain us the development of acetabula cup in THA. The increase of demand for the acetabula cup in THA is related due to post-operative dislocation risk. In this article also explain us that acetabula cup have two components, which is shell and liner. And then article from Aiman 2019 entitled the role of 3D printing in medical application. In this article explain us that many advantage of 3D printing in medical application. For example, time cutting by speeding up conception and prototyping. In this article also explain us there are many medical applications for 3D printing, especially 3D hearing aids, bioprinting tissue and organ, and acetabular cup. In this article also explain comparison between 3D printing and conventional manufacturing. And lastly, about locking mechanism. The article from Tang Pon Praset 2017 titled Design of Locking Mechanism on Acetabula. In this article, explain that they have two popular locking mechanisms, which is self-locking mechanism and assisted locking mechanism. Locking mechanism also have locking screw, which is for securing a set cup within a recess of surrounding bone.
Next, we move to the methodology. Under methodology, we have the analyze of the old product and the new proposed design. Now we move to analyze of the old product. In the old product, first we have the reverse engineering. In the reverse engineering, the first step is the digitization, and the second step is pre-processing. The third step is model verification. The third step is surface categorization, and the fourth step is model exploitation, and the final step is final modification. In final modification, if the model you want to use in the additive manufacturing, the IGS feature can be converted to the STL file to insert to the additive manufacturing machine. So next we move to the product description. And in the product description, in this discovery, the component for use in the hip prosthesis, which is hip replacement surgery. So the second is the acetabular cup has a statistically hemispherical very surface for the rotation of the femoral component head during the surgery operation. So next is the insert with or without the cement into the prepare hip socket. For the cementless, it is secured by the press fit in the prepare bone or screw directly in the place prepare bones. And the process that involved for the old product is injection molding. The other process that involved also that can be used in this product is compress molding and the other type of molding that for the to produce this product. Next is we move to the product structure. This is the structure of the acetabula cup. As you can see here, the inner liner is contact with the stem attached with the femoral head. In the femoral head, so it is consisting of three elements, which is acetabula cup, then the femoral head, and then the last one is metallic stem. As you can see here, the acetabula cup is mounted in the pelvic acetabulum. The femoral head is contact with the acetabula, and last one is metallic stem that fits into the femur. So to minimize the prevalence of the discoloration of the hip joint, which is the wear happen, so hip joint will be the discoloration of will be happen, then discoloration protection structure should be used. This is the bill of material of the whole product, which the first one is inner liner, which is made from the polyethylene or plastic. The second one, this is the titanium, of the acetabula shell. So the function of the plastic liner is used to overcome the problem of instability by keeping the femoral head inside the socket. So next is for the acetabula shell. It is used for hip replacement based on the bone pin intervention to provide initial stabilization.
Okay, for analyze the whole product of acetabula cup for the whole product is used material titanium. Mechanism of the whole product use titanium is to maintain initial long-term cut stability, mechanical fixation, and bone consolidation between the cut surface. The material of the titanium is provide a greater resistance to both detachment and corrosion. Why use titanium is for hip surgery because of the poor bone quality of the patient. For the weaknesses, titanium where surface will crack the oxide layer. The coating may be scratched and rubbed off, and 3D printed parts are cracking and delamination because of the structure solidification shrinkage. And when subsequent layer exceed the strength of the titanium of the acetabula cup, delamination phenomenon will occur. For the cost product, we can see that from the table, the cost of the ceramic or alumina is more cheaper more than compared to the titanium material for the acetabula cup. For the new proposed design for acetabula cup, which is we use alumina, the mechanism of the proposed design for alumina is alumina cup are made and welded permanently to reduce modulus buffer. The use of the alumina material is more rigidly from the surrounding bonds, possibly causing protective tension and bone reabsorption. And alumina is reduced composite support during manufacturing rigidity and avoiding the wear. For the selection of the material and AN system, the selection of the material we select is alumina ceramic that is consolidated into a carbon reinforced composite support to reduce the stiffness. In head hypothesis, alumina fatigue failure will not consider. Carbon reinforced composite will reduce the prosthesis modulus and encourage bone growth. The AM system or AM method we use is powder bed fusion. It's referred to as the 3D printing method or the manufacture of additive used to make the acetabula cup. How it works is the powder is deposited and recorded until the powder coating has been selectively diluted, and post-processing are required such as powder removal, head trimmer, or post-machining and the tire implant.
Hello, my name is Akmal Izzuddin bin Ismail, and I will explain about the result and discussion. But firstly, I will explain about the result. So firstly, the comparison between the old design and the new design. Okay, for the old design, we are using the outer shell, we are using titanium, and for the inner liner, we're using the polyethylene. And for the new design, we changed it to alumina ceramic and carbon reinforced. composite. For the method, we are using the conventional method, which are injection molding and compress molding. And for the new design, we are using additive manufacturing, which are powder bed fusion. For the mechanism, for the old design, we are using the self-locking mechanism. For the new design, we are using the incorporates alumina into the composite support of reduced stiffness. Next is the percentage part reduction or increase. As we can see, the old design and the new design consists of two parts, which is the first outer liner shell that made from the titanium, and the other is inner liner that made from polyethylene. And for the new design, also consists of two parts, which is the alumina ceramic bearing and carbon reinforced composite. Okay, so this is our new design acceptable cup. Okay, now we discuss the project. First is the discussion of comparison between old design and new design. And for the material, the old design is titanium for its outer shell and polyethylene for its inner shell. But the new design is using alumina ceramic and carbon reinforced composite. The old design using titanium, which is the most common metal, is in Hidayah and etc. The new design alumina ceramic is also have been accepted as valuable materials for the production of replacements of pieces of human bone. And for the fabrication method, the old design using conventional methods such as injection molding and compress molding. And the compression molding produced for the development of composite pieces to be used for metal replacement applications. Injection molding is a process of inserting heat-acted plastic material in a mold, then refrigerating and solidifying the molded object. For the new design, we are using the AM technique, which is powder bed fusion. And for the mechanism, all design, the interior of the shell provides a locking mechanism for locking a liner. The lock system must be sufficiently powerful to accommodate a shell and a shaft, since the unlocking of these two items is unsafe for patients. For new design, it incorporates alumina into the composite support of reduction stiffness. The suggested layout requires alumina in the composite support with reduced stiffness during processing. Next is the discussion of percentage part reduction or increase. The old design of acceptable cup consists of two parts, which is the first one of the shell that made from the titanium, and the other is inner liner that made from the polyethylene. While the new design consists of also two parts. First is alumina ceramic and carbon reinforced composite. So as you can see, the design don't have a percentage part reduction or increase. And next is discussion of feasibility and improvement. So for the for the new design, we are increasing the material. We are using alumina ceramic. Ceramic is good durability, much more resistant than metals and alloy to corrosion. Because of their high chemical tolerance, even in harsh conditions, they are passive against chemical corrosion. This corrosion resistance property is also one of the benefits of ceramic over metals, plastics, and other materials. The most well-known and most widely known fine ceramic material is alumina. The sinterate crystal body is the same as the sapphire and ruby. It is high strength and resistant to corrosion and wear, so it is suitable for substitute for titanium acceptable cup component in the old design. Next is the discussion of economical and mechanical justification and analysis. Firstly is the mechanical part. The acceptable cup shape is an aluminum ceramic bearing that is consolidated with decreased stiffness into a carbon reinforced composite support. Due to their high strength and hardness, which are determined by the heavy ionic bonding between the atoms, aluminum ceramic have outstanding resistance to various forms of wear. As for economical, some surgeons have been anecdotally saying a move for all ceramic on polyethylene (COP) implants. Patient to prevent metallic materials concerned because ceramic heads are more costly than metal heads. However, ceramic implants are more cleaner and tougher than their counterparts in cobalt, chromium, and dust weigh less. That may be a huge benefit for younger patients undergoing hip replacement because of less compression in old age.
As a conclusion, additive manufacturing has shown how AM is an interesting way of thinking about production as well as a modern way of constructing components. Usage in AM also including in medical sector, which it gives many benefits to the consumer, especially for the hip replacement part, which is acetable cup. The new process using powder bed fusion (PBF) to produce acetable cup give high strength and hardness compared to previous method. As a recommendation, the product cost of PBF is expensive, The product cost could be reduced, which it will allow the accessibility to more consumers in overcome their orthopedic issue. The change need to be done is by applying electron beam melting (EBM) method, because EBM can reduce production cost and speed time to market for high value components. Although this method is not inexpensive, it is far more time and cost effective. That's all for our presentation. Thank you.